quiz will be on Monday. We'll review a little bit tomorrow. So if you have handy dandy, that will be a good idea. We're doing identities again, verifying identities again. So same ideas, I'm just going to show you some other types of problems that you could run into. Now this is going to seem random right now, but I want to put up here a couple things about fractions real quick. Some of our problems today are going to have fractions in them, and I want to make sure that you know what you can do with fractions and something that you can't do. So this is a can do. We're going to put a smiley face by this one because this one makes us happy. If you have A plus B all over C. Now we're not going to have A, B, and C. We're going to have trig functions and numbers and all kinds of things. But the main idea here is that your fraction has a single term on bottom and multiple terms on top. If that is how your fraction is set up, you are allowed to basically break that fraction apart and turn it into A over C plus B over C. That is legal if you only have one term on bottom. Now, what you can't do, this is going to make us unhappy. What you can't do is break a fraction apart if there's more than one term on bottom. So if it was set up like this, single term on top, two terms on bottom, you are not allowed to break that apart and call it A over B plus A over C. It all depends on how many terms you have on bottom. Okay, if it's one term, go for it. If it's more than one term, don't do it. It's not allowed to be broken apart. So again, that seems pretty random right now, but I like to point that out because you're going to see something like this on the very first example today. It still says verify each identity. So same directions. Hi, come on in. Thanks. This is part 2 of section 5.2 if you want to jump in with us. Verify each identity. Okay, I'm going to let you copy this down. We've got 1 minus sine of x all over cosine of x, and it equals secant of x minus tangent of x. Verify the identity. So same structure as yesterday. Keep the right side, work on the left. I always forget that I already have that up there, so I don't need to write that out. Keep the right, work on the left. Now when I look at the left side, I kind of started to think about a Pythagorean identity on top, but this is not sine squared, it's just sine, which means I can't do a Pythagorean identity. Now I do notice that what I'm going for is not a fraction. This does not have a fraction in it. So it kind of tells me that I should probably try to break that fraction apart, which is legal in this case because there's a single term on bottom. I need to break that fraction apart so it's not one big fraction anymore. Now, when you do that, you'll start with 1 over cosine of x. The example I put up earlier had a plus sign. This is a minus. It doesn't really matter. But minus sine of x over cosine of x. Keep looking at what you're going for. How could I rewrite 1 over cosine of x? Secant of x, so that's nice. This is a reciprocal identity. 1 over cosine is secant. And over here, how can I rewrite sine of x over cosine of x? Tangent of x. That is a quotient identity. And so how nice was that? After just a couple steps there, one step really, just kind of breaking it apart, it ended up being exactly what we needed on the other side. Yes?
On the quiz, do you want us to write which properties that we use, or do you just want us to write the steps?
Just the steps would be fine. Yeah, you don't have to write those parts out each time. That's a good question. Just as long as I can see clearly from one step to the next what you did, then that's just fine.
If you went ahead and put tangent, and when we replace it with the reciprocal, the cosine, would you count that wrong, or do we need to show like one step at a time?
I would just show one step at a time. That way I know for sure like how you got your answer. Yes, good question. When I read through your work, I mean, we all know what the answer is going to be. So yeah, I would show as many steps as necessary just to make it clear what it looked like before you changed it. Good question again. Anybody else? Okay, I'm going to keep on rolling here, so stop me if you have any more questions. Example 2, more fractions. Cosine of x over secant of x plus sine of x over cosecant of x equals 1. Keep the right side, work on the left. Now, we do have fractions here, but it looks like these have already been broken apart somehow. I guess they've got different denominators, so maybe they didn't start out as one fraction. But it's not really something that you can break apart because it's just single terms on top and bottom. So I'm not really going to go that way, but I am looking at the trig functions right here and the trig functions right there. What's the relationship between cosine and secant and sine and cosecant? Reciprocals. So there's 2 different ways you could do this problem. I left cosine of x alone on top, and I changed secant of x using a reciprocal identity. I changed secant to be 1 over cosine. I didn't have to do it that way. I could have changed cosine to be 1 over secant and then left secant alone. You want to leave one of them alone because you're going to end up with something in common. Now on this side, be consistent. On the last part, I kept the top and changed the bottom. So that's what I want to do on the other side. Keep sine of x, change cosecant of x to be 1 over sine of x. Okay, so here comes the good old keep, change, flip. Dividing by a fraction is like multiplying by the reciprocal. So watch what happens right here. Keep cosine of x, change it to multiply, flip the fraction on bottom. What's a better way to write cosine of x times cosine of x? Cosine squared of x. I went ahead and put that down. Now, same thing will happen over here. Sine of x, keep that, change it to multiply, and flip that fraction on bottom. Sine of x times sine of x, the best way to write that is just sine squared of x. Okay, now, looking at what you have and what you're trying to go for, what identity should I use next? Yeah, that works out perfectly. Pythagorean identities. Now, the one that I'm looking at on Handy Dandy says sine squared of u plus cosine squared of u equals 1. We're in a different order, but addition is commutative, so you can switch those around, or you can just leave them like that and go ahead and say that this is 1 and 1 equals 1. Subtraction is not commutative though, so you can't switch around any of them that have a minus sign. Okie doke. Questions on example 2. I'm going to keep moving here. So, number 3, we're going to have one like this right at the beginning of the homework, I think. Number 3, cosine of x plus sine of x tangent of x equals secant of x. Okie doke. Now, keep the right side and work on the left. So I want to leave secant of x the way it is, and I need to work on the left side. Now, the left side is a little overwhelming because there are 3 different trig functions. So we need to start brainstorming how to rewrite something up there so it has something in common with everything else. So for example, is there a way to rewrite cosine so that it has a sine or a tangent in it? Or is there a way to rewrite sine so it has a cosine or a tangent in it? That's kind of what we're thinking. Now, does anybody have anything that they want to throw out for us? Quotient identity. I like the way you think. Tangent of x is the same as sine of x over cosine of x. So I'm going to leave this cosine of x plus. I'm going to leave the sine of x alone. But I'm rewriting tangent of x as sine of x over cosine of x. Right-hand side is still there. Okay, so let's make this part look a little bit better. If you want to put the sine of x over 1, you can. And then this is just like multiplying fractions together. So sine of x times sine of x, that'll be sine squared of x. And 1 times cosine of x, that's just cosine of x. So right here, cosine of x is still out front. This has turned into sine squared of x over cosine of x. And I know it's annoying, but you need to show both sides in each step so it still equals secant of x. Okay, now there's something about this that I don't like. The side that we're working on has a plus, it's a sum. And what we're going for is not a sum. And so I need to think of a way to get these 2 terms combined. And if you want to be technical here, this is like adding with fractions. What do we always need in math if we add fractions? Common denominators. You can stick that cosine of x over 1 and then think about what your least common denominator would be.
Cosine of x.
Yeah, very good. This is cosine of x. This is just a little old 1, but we could multiply that 1 by cosine of x to turn it into cosine of x. Now don't forget, whatever you do to the bottom of a fraction, you also have to do to the top. So we're on a roll here. Cosine of x times cosine of x, That is cosine squared of x. And on bottom, that's exactly what we wanted. Cosine of x times 1 is just cosine of x. I didn't have to touch that second fraction because it already had the denominator that I needed. And there's secant of x, still hanging out on the right-hand side. Now that we have a common denominator, we can keep that denominator and add our numerators. It's like taking 1/6 plus 5/6. You would keep the denominator, add the numerators. We can't really add too much right now. We're just going to leave it as cosine squared of x plus sine squared. Now, anybody see where this is going to go? Yeah, we had this on the last example, I think. Cosine squared plus sine squared is 1 using a Pythagorean identity. And now you can breathe a sigh of relief because this is pretty easy now. 1 over cosine is secant. I'm just going to think of my reciprocal identities right there. And that turns into secant of x. Okie doke. Back to the beginning. How did I know how to get started? I wanted to turn something into something that would be in common with our other trig functions. If we turn that into sine over cosine, this has sine and cosine, so I kind of knew that was the way to go. All right, questions on number 3. Okay, last 2 here, and I'm going to put a hint up on the board for this problem. I always do this on tests and quizzes too. The hint on this is going to be to factor. Okay, just to help you out a little bit on a test or a quiz, if there's an identity type of problem where you have to factor, I'm going to tell you that up front. That way you have a better idea of where to go. Okie doke. But still, keep the right side and work on the left. Now my hint is to factor. So, looking at this, what type of factoring would this be? Difference of squares. Very nice. So we need to set up, and I hope I have enough room here. I may have to scoot that over. I want to set up a couple parentheses to do the difference of squares. 1 is a plus, 1 is a minus. Now, what do you square to get secant to the 4th? Secant squared, very nice. And then, same with the tangent. We square tangent squared to get tangent to the 4th. So again, one of those has a plus and one of those has a minus. Now we're pretty darn close to what we need in this problem. If you look at the right-hand side, we need secant squared plus tangent squared. We have secant squared plus tangent squared, but we've also got this pesky secant squared minus tangent squared. We don't really want that. Now, if you're technical, what does secant squared minus tangent squared equal? 1. That is a Pythagorean identity. So this kind of goes back to the question earlier about how many steps do you really need to show. Even though you know what's going to happen here, still show that you replace that with a 1. so that I know how you did the problem. If you just jump to the very end and say secant squared plus tangent squared equals secant squared plus tangent squared, I might not really know how you got rid of that part. So show enough steps so that it is obvious. Okie doke. Now, last problem here. This will be example 5. Okie doke. It is a little bit different than the last few. It says cosine of theta minus 1 divided by cosine of theta plus 1 equals 1 minus secant of theta all over 1 plus secant of theta. Got a lot going on up here. Now, I'm going to go against my word a little bit on this problem. If we, don't write this down, but if we kept the right side and only worked on the left side, I mean, there's like nothing I can do over here to make this look any better. These are not Pythagorean identities because these cosines are not squared. And using a reciprocal identity won't help you very much because then you'll just have a fraction in a fraction, and same down here. So unfortunately, our method of keeping the right working on the left is not going to work on this problem. Now let's go back to algebra for just a second. What we have right here is technically a proportion. There's a fraction equaling a fraction. Do you remember how to solve proportions? Jay says no. Anybody? Cross multiply. Yeah, it's been a while, but to solve a proportion, you gotta cross multiply. And this is gonna get a little hairy because we have trig functions, but we're gonna do it the same way. Okay, I wanna go ahead and tell you too, this is absolutely the only time where we won't keep the right work on the left. If it's a proportion, this is the only exception to that rule that we had. Only time we won't keep the right and just work on the left. Okay, now I actually kind of like to think of each one of these in parentheses when I do this, just so my brain knows what to keep together. And it does not matter which diagonal you multiply first. I usually just go with this one. And so for right now, when I take cosine of theta plus 1 times 1 minus secant of theta, I'm just going to put them right next to each other for the time being. I'll have to simplify that a little bit more, but that's good for now. And then other diagonal, same thing, not same thing, but same way to do it, cosine of theta minus 1 times 1 plus secant of theta. I'm just putting them right next to each other. Okie doke. This is a binomial times a binomial. This is a binomial times a binomial. So what are we going to have to do on both sides? Foil. Yes, foil the left, foil the right. So here we go. Cosine of theta times 1 is just cosine of theta. Cosine of theta times negative secant of theta. I'm just going to put those together as negative cosine of theta, secant of theta. Inner terms, I would get a plus 1. And last term, 1 times negative secant of theta, that's just negative secant of theta. We have some work to do over here, but I'm going to forget that for right now and move on to this side. First terms, cosine of theta times 1 is cosine of theta. outer terms, cosine of theta times secant of theta. Let's just put those right next to each other. And then inner is -1. Last terms, I get minus secant of theta. You're basically working on both sides. You're trying to go as far as you need to get the left side to look like the right side. Now, what I'm noticing right now are these two terms right here. I had a question second period, I think. Can you just cancel those out? Because that's a minus and that's a plus. If they were on the same side, you could cancel them. But technically, if you moved this term to that side, you would have to add it since it's being subtracted, and then you'd have two of them. So they don't really cancel, but I'm noticing something kind of special about them. What do we know about cosine and secant? Reciprocals. Let me come up here for just a second and show you how these can be simplified. If you, for example, leave cosine of theta and rewrite secant as 1 over cosine of theta, or you could have done this the other way, the cosines drop out and you just get 1. So I'm going to go ahead and start to write some of this out. Let's leave cosine of theta up front. I'll leave the minus sign. And what I have right here in this blue box just turned into 1. If you take a function times its reciprocal, it should be 1. Take 5 times 1/5, 1. 4 times 1/4, it's always going to be 1. Now, you also have the plus 1 and the minus secant of theta. I'll come back to that side a little bit more here in a second. Same deal on this side. You can put cosine of theta and the plus sign back down, but when I take a trig function times its reciprocal, it always simplifies to 1. And then I still have a minus 1 minus secant of theta. And this should really be my last step, because if you look over here, -1 plus 1, those can cross out. Right here, same thing, 1 minus 1, that's just 0. And look at what you have on both sides. Cosine of theta minus secant of theta. Same thing over here. Cosine of theta minus secant of theta. That's how I know that I'm done, when I get the same thing on both sides. Okay? Again, this is the only exception to the rule about keeping the right working on the left. Anytime it's a proportion, then that's the way you need to go. I'll leave that up there if you still need it. I'm going to pass out the assignment. It's not out of the book. It's off of a worksheet. However, I don't think there's enough room to do all your work on here. So you may want to take out a sheet of paper and label it T35. That way you know where it goes. And I think I want to start you with the first one just to kind of get us going here. So number 1 we'll do together, and then I'll try to give you another hint or two. Now I will say there is one proportion on here. Do you see which one that is? Number 7. Yeah, number 3 almost looks like a proportion, but 7 you want to cross multiply. There's also only one that you should factor, and that is number 8. So hint about number 8, you want to try and factor that. I think that's another difference of squares. So, like I said, let me get you started with the first one. It is similar to one of our problems from the notes. So let's do that one together. Secant of x minus tangent of x sine of x equals 1 over secant of x. All right, keep the right, work on the left, unless it's a proportion. Keep the right, work on the left. Now I'm trying to think about what all three of these could have in common. And it's about the same as our example from the notes. I forget which example it was. It was number 3. But all of these could have something in common with the quotient identity. I'm definitely going to change tangent to be sine of x over cosine of x. But speaking of cosine, I could also change secant using a reciprocal identity. I could change that to be 1 over cosine of x. So let me catch up to my brain here. I'm doing more than I'm writing. This is the reciprocal. This is a quotient identity. And I'm just going to leave sine of x alone, or even better, I'm just going to put it over 1. I don't need to change it because it already has something in common with this. Okie doke. Now, we need to make this look better, just like we did with number 3. So sine of x times sine of x, that would be sine squared of x. Cosine of x times 1 is cosine of x. And there's the right side, still hanging out. Now, this is actually a little bit nicer than our example earlier. With number 3 from the notes, we had to get common denominators to put these fractions together. These already have a common denominator. So I'll put cosine of x on bottom, and now it says 1 minus sine squared on top. Okay, well, what is 1 minus sine squared of x? Cosine squared. This is a Pythagorean identity, and it turns into, I'm not going to have enough room down here. I'll have to swing this up, but that turns into cosine squared. So what do you get if you take cosine squared divided by cosine? Cosine. Now, I'm just about finished. If you do what we've been doing, keep the right side, work on the left side. You can just change cosine of x to be 1 over secant of x. Or I'm not going to count it wrong if you keep cosine and change that to be cosine. That would also work. But a little bit nicer there since you already had common denominators.